Hi everyone. In today's class, we are going to see the solution for the partial differential equation using Lagrange's multiplier method. Solution for PDE using Lagrange's multiplier method. Let us see the procedure to solve this Lagrange's method. The general form of the PDE should be in PP plus QQ equal to R. For applying Lagrange's multiplier method, the given problem is in the form PP plus QQ equal to R. Then the auxiliary equation for the solution is dx by p equal to dy by q equal to dz by r. This is our auxiliary solution. That means the source equation to find the solution for this problem. Now this problem is in the general form pp plus qq equal to r, and the auxiliary equation is dx by p equal to dy by q equal to dz by r. And then how can we solve this problem? Let us choose the two set of multipliers for finding solution. Two set of multipliers to find the solution. This multipliers is called a Lagrange's multipliers. These multipliers are called Lagrange's multipliers. So this is the general solution to solve the PDE using Lagrange's multiplier method. This problem should be applied only when the given equation is in the form PP plus QQ equal to R. After that you have to write the auxiliary equation. Then substitute the values for P, Q, R from the given equation. After that choose the two set of multipliers to find the solution. Let us see the example for this method. So this is one example to apply Lagrange's multiplier method. In this example, see the general form of the solution. Let us see the solution for this problem. The given equation. What is our given PDE? Given PDE is x into y minus z into p plus y into z minus x into q equal to z into x minus y. This is our given PDE. Then clearly, this is in the form PP, this is our capital P, then QQ, this is our capital Q, and right hand side is considered as R. This is in the form, clearly we are directly see that PP plus QQ equal to R, so that we can apply Lagrange's multiplier method to find the solution. Then consider what is P, given that from the problem, given that what is capital P? Capital P equal to the coefficient of small p, that is x into y minus z. What is our capital Q? Capital Q equal to coefficient of the small q, that is y into z minus x. Then what is our capital R here? Capital R equal to z into x minus y. From the given problem, we are able to write P, Q and then R value. Then what is our next step? As said earlier, our next step is to find the auxiliary equation. Let us write the auxiliary equation. Our auxiliary equation is auxiliary equation. How can we solve the auxiliary equation? What is the formula? Dx by capital P equal to dy by capital Q equal to dz by r. This is our auxiliary equation to find the solution. Then substitute the values for P, Q and then R. Substitute the values for P, Q and then R. This equation will be dx by sub P, Q, R values. Sub P, Q, R values. Then the auxiliary equation change into dx divided by x into y minus z plus equal to dy divided by what is our capital Q here? Y into z minus x, and then dz equal to our r is z into x minus y. Just write the auxiliary equation and then substitute the values for p, q, r respectively. Then what is our next step? Next step is choose the multipliers. Choose the multipliers. Before that, see the procedure. At the first stage, we have to check whether the given equation is in the form of PP plus QQ equal to R. PP plus QQ equal to R. The first condition satisfied. So that we can able to write the auxiliary equation dx by P equal to dy by Q equal to dz by R. After substituting the values for P, Q, R, we can choose the multipliers. Two set of multipliers to solve the PDE. Now, let us see how can we choose the multipliers to solve this solution. How can we choose multipliers to solve this? We have to choose two set of multipliers. We have to choose two two set of multipliers for case 1. Let us consider the case 1 for multipliers. Case 1, choose multipliers. How can we choose the multipliers? By checking the final answer for the denominator will be vanished. The final, whether we subtracting or adding the denominator values, we can get the zero solution. According to that condition, we have to choose the multipliers. In this problem, simply if we add these three denominators, we can directly, how, x into y, xy, minus x into z, minus xz, and then y into z, yz, plus yz, and then minus yx, then next denominator zx, minus zy. So this yz cancelled, xz cancelled, yx cancelled. So the denominator will vanish. So we can choose the multipliers. As it is, we are adding, get the denominator zero value. So that I choose 1, 1, 1 as multipliers. Choose 1, 1 as multipliers in case 1. This is our first case. Then if we choose 1, 1, 1 multiplier, means what is the procedure? In numerator 1 into dx, then 1 into dy plus 1 into dz. In denominator also 1 into x, again we will get x. So x into y minus z plus y into z minus, because we are multiplying by 1 only. 1 into y, again it will be y. In 1 into z it will be z. So z into x minus y. Then what is the answer? In numerator dx plus dy plus dz divided by, in denominator, just to simplify this one, x into y, xy minus xz plus yz minus yx plus zx minus zy. Then how can we cancel this one? Simplify the denominator. How can we cancel this one? If we are simplifying, these two terms will be vanished. How it will vanish? Xy and minus xy will get cancelled. Then xz and plus xz will get cancelled. Yz and minus yz will get cancelled. So our final solution is dx plus dy plus dz divided by, the denominator is vanished. The denominator is vanished. This can be rewritten as, dx plus dy plus dz equal to 0. Dx plus dy plus dz equal to 0. Now we need the solution. So just to integrate this equation, integrating this differential equation, integrating we get, how can we integrate? Integral dx plus integral dy, term wise integration, integral dz equal to 0. So integral dx is x, integral dy is y, and integral dz is z. When we are integrating the indefinite integral, we have to add an integrating constant, that is c1. We have to add one integrating constant, that is c1. So after considering the case 1, the first solution, C1 answer is considered as U. C1 answer is considered as U. This is our first solution for case 1. So I take this CS U equal to X plus Y plus Z. This is our first set of solution. This is our first set of solution. So after considering the multiplier 1, 1, 1, we find one solution. This is our first set of solution. This is our first set of solution. Okay. Now let us move to case 2. Let us move to case 2. In case 1, we get one solution. Then let us move to case 2. How can we find case 2? Let us try. Case 2. We have to choose different multipliers. In case 1, we are choosing 1, 1, 1 such that the denominator is 0. What is our denominator here? X into y minus z plus y into z minus x plus z into x minus y. This is our denominator. This is our denominator. We have to choose the multiplier such that the denominator should vanish. The denominator should be vanished. Now, already 1, 1, 1 multipliers are chosen. Then, how can we get the another multipliers? What are the coefficients here? X, y, z. Suppose if we are cancelling this coefficient by multiplying 1 by x, 1 by y, 1 by z term wise. Then the first term will be 1 by x into x get cancelled. So the answer is y minus z. Suppose the second term is multiplied by 1 minus y, means it will be z minus x. Similarly for third term it will be x minus y. So all the terms get cancelled, the denominator vanished. So in case 2, the multipliers are, in case 2, multipliers are, what are multipliers? 1 by x, comma, 1 by y, comma, 1 by z. So that the denominator is vanished. So this is our second set multipliers. This is our second set multipliers. Now, consider this multipliers. In numerator, we have to multiply it by 1 by x into dx. Then dy is multiplied by 1 by y and dz is multiplied by 1 by z into ds. What about the denominator? This 1 by x into, already we are having x into y minus z. Then multiplier is 1 by y. Then what is the actual term? What is the actual term? Y into z minus x. Then for third term, our multiplier is 1 by z. Our actual term is z into x minus y. Z into x minus y. Now, simplifying this denominator, how can we simplify this denominator? X get cancelled, y gets cancelled, z gets cancelled. Then what about the remaining term? Dx by x plus dy by y plus dz by z. Then denominator, what about the denominator? Y minus z plus z minus x plus x minus y. Now simplifying this denominator, we can get this y and the minus y will get cancelled, minus z plus z cancelled, minus x plus x cancelled. So the denominator is vanished. So what about the remaining? Dx by x plus dy by y plus dz by z. Denominator is vanished, 0. This can be rewritten as dx by x plus dy by y plus dz by z equal to 0. Now, how can we find the solution? As usual, integration. How can we integrate this one? Integrating we get, then integrating we get, integrate termwise integration, dx by x plus integral dy by y plus integral dz by z. What about the integration formula for integral dx by x? Clearly it is log x, because denominator differentiation appears in numerator. So log of denominator is our integration formula, log x plus log y plus log z. We have to add one integrating constant. In left hand side, all our integrand in terms of log. So I add the log integrating constant as log in terms of logarithmic term, log C2. Already we are using C1. So for our convenient, we have to choose the integrating constant as log C2. What about the log x plus log y plus log z formula? Already we are very well know, log x plus log y plus log z is equal to log of xyz. Log of xyz equal to log C2. Log of xyz equal to log C2. If we are taking exponent, the exponent and log will be cancelled. So what about the final answer? Xyz equal to C2. Xyz equal to C2. In first case, we considering the C1 answer as U. In second case, we will consider the C2 answer will be B. So B equal to XYZ. In first case, we are considering C1 value as U. In second case, we are using V. For our convenient, we are using V. So the second answer is B equal to XYZ. B equal to XYZ. Now, write the general solution. How can we write the general solution? The general solution for the PDE. The general solution for the PDE. The given PDE is phi of u comma v equal to 0. Phi of u comma v equal to 0. That is phi of, what is our u? What is our u here? Here u is x plus y plus z, x plus y plus z, and our v is xyz equal to 0. Phi of x plus y plus z and phi of x comma phi of xy z equal to 0. So this is our general solution. So phi of, this is our general solution for the given problem. Let us summarize this procedure once again. Now we are in this class, we discussed about the solution of PDE using Lagrange's multiplier method. For this we have to check first condition. whether the given equation is in the form of PP plus QQ equal to R. PP plus QQ equal to R. First condition. After that, we have to write the auxiliary equation as per the given rule. Dx by P equal to dy by Q equal to dz by R. And then choose the multipliers once again. Now, in this example, the given equation clearly is in the form. In this example, the given equation is in the form of PP plus QQ equal to R. Now, from the given equation, we are able to write PQR value. Then our auxiliary equation. What is our auxiliary equation? Is dx by P equal to dy by Q equal to dz by R. Then substitute the values for PQR respectively. We can get this auxiliary equation. Now, as per the procedure, choose the multipliers, two set of multipliers. In first case, we choose the multipliers as 1, 1, 1. In first case, the multipliers, choose the multipliers 1, 1, 1. That is, as per the given data, we are adding the denominator will be vanished, so that I consider the multiplier as 1, 1, 1. So after simplifying this one, we will get dx plus dy plus dz equal to 0. This equation is integrated. Then x plus y plus z equal to c1. This c1 is taken as u. That is u equal to x plus y plus z. This is our first solution. Then in case 2, you have to choose another set of multipliers 1 by x, 1 by y, 1 by z, so that the denominator will be vanished in this category. If you choose 1 by x, 1 by y, 1 by z multipliers, the denominator will be vanished. The remaining term is dx by x plus dy by y plus dz equal to 0. Then integrating this one, left hand side is log x plus log y plus log z, but log x plus log y log z. Generally, we are adding the integrating constant at C2, but all the terms are in terms of logarithmic. So, we introduce the constant also in logarithmic log of C2. After taking exponent, after taking e power log, this will be cancelled. So, the final answer is x, y, z equal to C2. This C2 is considered as V equal to x, y, z. Now, write the general solution for the given problem. The general solution is phi of u comma v equal to 0. Substitute the value for u and v separately. Substitute the value for u and v. Here the first one is u, and then second one is v. Finally, we can get the answer. Thank you. We will see in next class. Thank you.